Okay, now we're going to deal with transformations of functions, and this uses those parent functions or basic functions quite a bit in this section here. So we are going to probably have maybe 3 or 4 videos dealing with transformations of functions. There's lots of transformations to look at. This video will start off with what I think are the easiest ones to deal with, and these are vertical and horizontal transformations. So there's 4 of them here, 2 verticals and 2 horizontals. So let's see here. Let's let C be a positive real number. And f at x be a function. Now before I write down the transformations, let me emphasize why I want C to be a positive number, because I'm going to be adding and subtracting C in various cases, and so I want it to be positive because then I know I'm adding a positive number or I'm subtracting a positive number, where if I let C be any number, then I'd have to be concerned about, well, what happens if C is negative? Because if you subtract a negative number, it's the same thing as adding a positive. So that's why we let C be a positive real number. So because we're going to be both adding and subtracting, we don't have to worry about double negatives going on. All right, so let's go ahead and look at this here. So we have a vertical shift up by C units, and this is going to be h at x is equal to this function f at x plus c, which you might guess that you would just add c, and if you think about it, like x squared plus 1, you're just going to be moving every point up 1. And you might guess the next one here is going to be a vertical shift down by C units. And again, you might guess if it's f at x plus c. For a vertical shift down, it would be f at x minus c. Now, this is where things I think start confusing people, is in the horizontal shifts. One, how to recognize a horizontal shift versus a vertical shift, and number 2, it's opposite what maybe your intuition would be, because my intuition would be, well, up would be adding, down would be subtracting. A horizontal shift to the right by C units. Well, this is actually going to be h at x equals f at x minus c. So going to the right, we subtract the c, but the key thing here is, look, it's f at x minus c. So that minus c is going to be part of that x parameter, or x term. And I'll show you in an example here quickly what we mean by that. And then the final one, which you can probably guess, is a horizontal shift to the left by C units. And this would be h at x is equal to f at x plus c. So these are the only transformations we're going to talk about in this video. But as I said, let's go ahead and quickly see the difference between a horizontal and a vertical one. So let's look at here, I'll call this just h sub 1 of x being x cubed plus 3. Now in this case here, I'll go ahead and identify, because this is going to be a process that we're going to want to do for when we're plotting these. The parent function of this is x cubed. Let me write one more function down. h2 at x is equal to the quantity of x minus 3. Or let's just go ahead and do x plus 3 so we keep both pluses in the case, not squared cubed. Okay, so we got h1 and h2. For both of these, the parent function is x cubed. And how can we tell? Well, this one I think is pretty easy to tell that it's x cubed, because you simply just have an x cubed sitting here. Here, well, what do you have? Yeah, I know I have quantity x plus 3 cubed, but if I took away that plus 3, it would just be x cubed. So again, the parent function is x cubed. But in this case here, h1 has a vertical shift up 3 units, and h2 has a horizontal shift left 3 units. And if we look at these, hopefully it's pretty obvious what the difference is. Here, you're cubing the x first, then adding 3. Here, you're adding 3 first, then cubing. So if you add the number first before doing what the parent function operation is, that's a horizontal. If you do the parent function operation first and then add another number, that's a vertical shift. And so this works regardless of whether the parent function is x cubed, x squared, square root of x, 1 over x. If you're going to do the parent function first and then add a number, that's going to be a vertical shift. If you add a number first and then do the parent function, that is a horizontal shift. So let's look at a couple examples here. Let's actually just, on this example here, we're going to graph some as well, but let's, for this one, just identify the transformations. We'll say identify the parent function and transformations present. Okay, so what do we have here? Well, let's look at h at x is equal to the square root of x minus 2 plus 5. So this is an example, and this is going to be the case with lots of the problems we're looking at, is that we're going to have more than one transformation present. So you have to identify the parent function, which hopefully it's pretty obvious what the parent function is here. Parent function is f at x equals the square root of x. But now we have to identify the transformations. Well, remembering what we just talked about, if we add or subtract a number first, then do a parent transformation, or a parent function, that's a horizontal transformation. If we do the parent function first and then add a number, that's a vertical transformation. So let's first look at here this minus 2. Well, x minus 2, of course, the minus 2 is done before I would do the parent function, because the parent function is square root. So that means I've got a horizontal shift, and because it's minus 2, this is a horizontal shift to the right by 2 units. And now I've got a plus 5, but the plus 5 is occurring outside of the parent function. In other words, I have already done the parent function, and then I'm adding 5. So that means it's a vertical shift up by 5 units. So that's all we were asked to do in this particular example problem. We're going to look at a couple more example problems here. But before we look at a couple more example problems, let's go ahead and, well, no, we'll just start with a new example here. So we're going to identify parent function and transformations then sketch the graph. Now, when we do sketches of these graphs, I want to see the parent function sketched and then also the transformation function. So let's first look at what it is we have here. So we have h at x. I'm going to do another square root one here. Square root of x plus 1 minus 3. Now, identifying the parent function, well, we know the parent function here is just square root of x. And then, well, I've got a plus 1 inside the square root, so that's happening before I do the parent function. So that is a horizontal transformation then. Now I'm adding 1, so with the horizontal shifts, remember that's a horizontal shift left by 1 unit. And then I've got a minus 3 outside of the parent function, or being done after the parent function, which means it's a vertical shift. And since it's minus 3, this would be down by 3 units. Okay, so let's sketch a graph of this. Okay, so as I said, when we sketch these graphs, we're going to want the parent function first. And so that's why we need to have those parent functions in the previous video well known. So square root of x, though, just got to plot 3 points, 0, 0, 1, 1, and then 4, 2. And then what I'm going to do here is, instead of actually drawing a solid line, I'm just going to do some dots here, just so it's clear what my parent function is, and then I'm going to draw the actual function h at x. Now, I'm doing a vertical shift down by 3 units and a horizontal shift left 1 unit. So literally all we're going to do is move those points according to the shifts. So we're going to go down 3, 1, 2, 3, and to the left 1. And then we're just going to do that for every single one of these. 1, 2, 3, to the left 1, 1, 2, 3, to the left 1. And so these blue dots then are actually points on the graph h at x. Now, all we've been doing is shifting it up, down, left, right. So the shape doesn't change or anything like that. So we just get to sketch the exact same shape through here. Well, roughly here. That wasn't a great sketch. So let's try that again. Sketch the same shape through here. Remember, it's kind of a half a parabola shape. And then this would be the sketch of h at x. Let's look at one more example here to wrap this up. Let's look at f at x is equal to 1 over x minus 2 minus 1. And do the same thing, identify the parent function and the transformations. Yeah, let's find the right f at x here. Parent function. Well, what's my parent function? The parent function is simply 1 over x. And then, well, I have x minus 2 inside parentheses, so that's being done before I do the 1 over it. And so that means I have a horizontal shift. Right 2 units. And then I have minus 1 outside of the parent function after the parent function's been done, which means we have a vertical shift down 1 unit. Okay. Oh, come on. It's not letting me move the graph here. Let's try this one more time. What is going on here? There we go. Sometimes it doesn't like to do what it's supposed to do. Alright. So, again, sketch the parent function here. So we've got, now it's trying to move it, and I don't want to move it. 1 over x. So we have a point at 1, 1, negative 1, 1. And then I'll go ahead and add in the other ones here as well. And then, again, I'm just going to kind of do some dotted line here to remind me of the shape. Okay, so that's 1 over x. Now, just like we did in the previous example, we're just going to move each point by my transformations. So I'm going to do horizontal shift to the right by 2 units and then down 1 unit. So I'm going to go to the right 2 units, 1, 2, and then down 1. Shift 1, 2, and then down 1. Shift 1, 2, and then down 1. And then the same thing with these. So 1, 2, down 1. 1, 2, down 1. Actually, this point should be maybe more over there. 1, 2, down 1. Now, when we sketch this, this is going to be the same. Now, sometimes people have problems sketching this, and so what I mean by that is, well, we have this thing called a vertical asymptote, which we'll talk about more later on. Right here, kind of do a dotted line right there. Well, that moves 2. Technically, it moves over 2 and down 1, but moving it down 1, since it's infinite, doesn't really make much difference. But that means there's still going to be one right here. And so, to kind of guide you here, this is going to go down like this, and then still, oops, and then to here, and then this is going to go down to here, and then up to here. And again, because everything shifts to right 2 and down 1, so this how everything's are approaching the x-axis, well, I have to shift that down 1 unit. So the 1 over x's are a little bit more challenging to do the transformations on, but it's still the same process. You just shift to the right 2 units and then down 1 unit on this example. Alright, so this wraps up for horizontal and vertical shifts, and in the next video we're going to talk about reflections and about the different axes.